Alright, good evening and welcome to my YouTube channel. Today we are going to be looking at linear regression with Python. We are going to learn how to build a linear regression model and how to visualize our regressions, or how to visualize our data with scatter plots and a lot of things over here. So if you have not subscribed to my YouTube channel, please hit the subscribe button and let's explore this together. First of all, we would like to import our data, our libraries that we want to use. We want to import our libraries that will help us execute this code very easy. So we want to get in pandas. We want to import our data set. So we want to bring in pandas library that will help us import our data set, which is our CSV file. We'll also import the matplotlib package because we like to do some visualizations over here. And then we'll also want to import seaborns that will help us do some regressions from scatter plots over here as well. And then we want to use our Scikit-Learn for our linear model. We want to build a linear regression model, so we would like to use from the Scikit-Learn. We want to import this linear model over here. And usually what we do with model building is to split our data into two parts, one for training and then one for testing. So we would like to get this library over here, and that one will help us split our data into a training data set and a testing data set. That is a part we're going to train our model, and a part we'll use to test our model. So I'll just execute this, so I can just click on this cell over here and click on the run button here to execute. So it's still executing. It will be done very soon, and once it's done, we'll go ahead and then import our data set and then use it. So you can see that below the second code, that is the second code over here, you can as well see that I'm going to import this data set. That is the census. I have a data set called census, and I have a folder name was data data, where I store my data, my file, that is my data sets over there. So I'm going to get the census data set from this folder, which is located in my documents. I'm using a mark so you can see that as well. And when that is done, I'm going to assign it to a name, my data. And after which, I'm going to just ask Python to give me the head, that is the top 5 variables, or the top 5 observations from my data. So if I hit the run over here, it's going to assign this data set to a name called my data, which is then help me to then be able to generate the second one, which is give me just the top 5 observations. So if you hit your run, you see that we've done that, and then you can see that this is the data. We have the state as a variable, a column name, we have the state 2, then we have region, we have the population, and then we have median age, we have death, we have marriage, and then we have divorce, right? So if you want to describe the data, if you want to find the summary statistics from your data, you would then like to use the describe button to be able to get your statistics, right? So if I hit this command over here, or if I hit this code over here, I'll then be getting my summary statistics over here. You have the population, you have marriage, you have death, and then you have divorce over here. And then you have the count, which is the number of observations. You have the mean, the standard deviation, the minimum value, the 25th percentile, the 50th percentile, and then the 75th percentile. Then you have the maximum value for all numerical variables. Note that when it comes to finding the summary statistics, we normally do that one with numerical variables, that is numbers. You cannot find summary stat for state, because state is categorical. So the Python itself will ignore this categorical data set or categorical variables and give you only summary statistics for the numerical variables. And I want to build a model. I want to study divorce cases or marriages and then population. So I want to build a model in the latter page where you'll be having divorce as a dependent variable, and then marriage and population as the independent variable. So I want to study the relationship between what marriage and population on what divorce, right? I want to know, is it that increase in marriages will lead to increase in divorces? Does high population what lead to what high what divorces? We want to know that. So if you don't want, if you are not satisfied with these statistics over here, you can single out these variables that you want. That is the marriage, the divorce, and then the population is over here. You can single out them, and you can describe them. You can find the summary statistics for just these three, and then you have them here. The same thing over here as well, but here you just want to what, bring out the three. That will help you what, focus on just these three variables, and you'll be able to what, identify patterns in the data set. And fast approaching, one thing we normally want to do in our data set is what, find the correlation coefficient for all the variables. Are they having a high correlation coefficient? That will help us what, do our modeling very well. Are they having a low correlation coefficient as well? And then when you just add the dot call here, I'll just single out this variable and just add the dot call over here, and that will give me the correlation coefficient for the three variables over here. So when you hit the run, you have it over here, then you can see that what marriage and divorce has a very strong correlation coefficient that is around 0.93, right? Almost 1. It's almost approaching a perfect correlation. And that is true because we expect that what, as you have more marriages, you should be having what, more divorce cases. And then we have as well marriages in the population. That one too is 0.9, right? Almost getting close to 1, which is perfect. And that one too is making sense. What that means is that what population and then what marriage, they move hand in hand. You know, as the number of people increases, probably marriages to rise. And we can also as well visualize some of this data over here. And I'm going to use the Seaborn package, which is over here, which is the SNS here, and I'm going to as well apply somewhat matplotlibs over here for my labeling. So matplt is here for what, my matplotlib.pyplot, and I have Seaborn over here. So I want to get a scatter plot, right? I want to get a scatter plot between marriage and the what, divorce, and I want my marriage to be on the x-axis, and then divorce to be on the what, on the y-axis, right? And I'm going to set the color to be equal to blue. You can as well change the color if you want to, but I want to set the color to be equals to what, blue over here. Alright, you see over here, and you see this is what the line of best fit, and that one is showing what a positive correlation between what marriages and the what divorce. And what you can derive from this is that maybe as marriages increases, or you have more marriages, then you'll be having what, more divorce cases as well. If you have more marriages, then you are going to be having what, more divorce cases from our data. And here you can see that we have the standard error, which is this line over here. Talks about the standard errors, right? So as you increase or as you go along this line, you can see that the standard errors what increases. The standard errors increases all in. But you can also change this line to red, this color to red if you want to. If you want to, you can change the color to red. But I prefer leaving it at blue, so I'll just leave it as what, as blue. I'll hit the run again to get it. And also, it's good to also look at the population and then divorce. Normally, because our divorce is the is how do you call it, dependent variable, or our y, I want to just look at population and marriage on one divorce. You can as well look at what population and what marriage to see how to be able to look at how data is going to be. You can as well look at that as well, and I'm going to hit that as well. This plt.show is not really that significant. You can as well leave it. If you don't bring this code, your graph will still appear. So it's just there to suppress some write-up that comes below it. But if you don't bring this plt.show, if you don't bring this one, then it is as your graph will still appear over here. Alright, so now we have this data, then we want to what, split our data or separate our data into our y and then our x. We want to determine what population and what marriage. We want to study the relationship with divorces. So it's good we assign some values to our x's, that is our predictors, and then we are going to also get our our target variable, which is the y value or the y what variable. And so with the x's, I have just what population and marriage, and my y is also going to be what a divorce, where I'll look at that. So you can assign this over here, just follow the code, and you will get it. Right. So normally what we expect the x to be is like a matrix. Matrix is something that has um, rows and columns, right? They have rows and columns, and it is not just a vector. So you see here you have what population and marriage. But what we expect the y to be is a vector, right? A vector is just a single what column, because that's a vector, right? Y is just one. But with parameters or with our x's, you can have two or three or more, or two or three or four x's, or what four what predicted that you want to study the relationship with what with that of the y. So if you look at the shape over here, you see that we have what 50 by 2. That means we have what 50 what rows and then what 2 columns, and the columns here will be our population and then our marriage. And then you can look at the head. There's the top 5, and then you see that what you have just what population and what marriage. If you want to display the top 10 inside the head, you can just type in 10 and hit your round again, and it's not going to give you what the top 10. The counting start from 0, so it makes sense if here is 9. So you start from 0, so you have 0 up to 9, and that is 10, right? So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But if you're going to add a 0, that will be 10. Alright, so I'm just going to leave it back at the head. And let's also look at our y shape. Y is going to be a vector. Now you see that you have 50 comma what dash. That's a vector, right? You just have just a single array, right? Just a single array of numbers, and that's just a vector, right? You do not have a matrix, and that is how we want to build our model. You can equally look at what the y, the head as well over here, and then you can also look at the tail, and the tail is the bottom, right? The tail is the bottom 5. You have the head, which is the top, and tail is the bottom 5. You have the tail, feet, and tail is bottom 5. You have 45 up to what 49. Remember, we have 50 observations, right? So 49 plus the 0, that will give us what the 50. Remember, that 0 2 is also an observation. So let's go back to our head. Let's clean this and type our head. Right. And now we want to split our data into what? One we are going to use to test, and one we are going to use to train. So on my x-axis or on my x values, I'm going to split into 2, and split my y values to 2 as well. So with this x over here, with this x over here, I'm going to divide into 2. One for my training, one to train my model, and the other one to test my model. So after building my model, I'll test it on the other one. Because normally with predictive modeling, you want to be able to build a model that will be able to do well or do very good on data it has not seen before. So it's good you divide your data into 2 and be able to test it very well and see if it's able to predict very well on the other data set. That's the test data set. So that you be sure that if you send this model outside, and if it sees any data that it has not come into contact before, your models will be able to predict that one very well. So I'm going to divide this, and I want to let at least use 20% of my data for testing, and the remaining 80% for my training. So I will set aside 20% of my data and use the remaining 80 to train my model. And I'm going to set this random state to be equal to 100. You can let it be any number if you want to, but this will ensure that we have the same values over and over again. Alright. And now you can print them. Length here is just going to tell you the number of observations over there. So this one is just something I want to bring along. I want it to appear along my x underscore train. Remember, it is in quotation marks, and that is how we write strings. That is how you write things that Python doesn't know. Coffee, Python doesn't know coffee, or Python doesn't know AMA. But if you put AMA in a quotation mark, it wouldn't see it to be a code. So it will display it for you as it is. So I'll just hit this. Alright, you see that our x train is 40 and our y train 2 is 40 as well. It means that I'll be able to split my y values over here, which is the y value over here. 40 of them, I've set aside 40 observations over here to train my model. And on the x over here too, I've set aside 40% or 40 observations over here. That is 80% to train my model. So the y here is 40 observations. In other words, 80%. You can print this one too as well. Alright. Remember here we said that we want to set aside 20% of my data for testing, right? So if you use 0.2 times 50, which is the length of my data times this, you should get 10. If you run it, you should get 10, and that means that we'll be able to set aside 10% of our data for testing. So now we want to build our model. So we want to assign our model linear regression to a name called model for our building, right? So I'll just execute this, and then we want to fit our model to the x train, y train. This x train over here and y train. This is the 40 of the observations or the 80%. We want to train our model on that on those observations over there. So I'm going to fit it. And right, you are able to fit your first linear model, right? You should just sit down and then take a coffee, right? Take some drink or take some water, because you have been able to build your first successful model. That is a linear model for yourself. So this is a model you'll be able to build. That's a linear regression model. And you can as well try to print out your parameters. You have the intercept, and then you have the coefficients. Intercept is the beta naught, and coefficients here is the beta 1, the beta 2, etc. Right? So this coefficient, and you see that I'm going to print this, and I'm going to print model.coef, that is the real code, and the coef here you have underscore, and that underscore means that give us the estimates for the model, right? We cannot get the actual. We want to make sure our model, our estimate is close to the actual. It's very, very close to the actual, right? So we're going to print out the estimates of this model, and that will be our parameters. So here you have you have 0.003455. That is the coefficient for population, and you have 0.1798. That's the coefficient for marriage, right? And then we can go ahead to print out our intercept as well. We have an intercept here, which is negative 309.483. That is our beta naught or our intercept, right? So it means that our model is going to be equal to the intercept here, which is negative 309.483 plus 0.00345, our population, plus 0.179 multiplied by our marriage, right? So I'm going to print this out. So this is how our model is going to be. If you want to write the equation, or if you want to write the equation of our model, this is how it's going to be. So you have been able to build your model, and then you now want to predict our y. Remember, we set aside we set aside this y test over here, right? This y test, which is the 10. So we want to use this x test, which is the 10%, to predict this y test. We assume that we don't know the y test, but we want to use the marriages and the population from this data set over here. That's the x test. And I say x test, so you can just say, let's just say x test. We want to print out x test. Alright, I mean the x should be in caps lock. The x should be in caps lock. So we're going to set aside this. Let me just display all the 10, because that is what I wanted. This is the 10 observations that it has been able to sample. So the code we use sample observations 6, 36, 37, 28, 43, 49, 5, 35, 20, and 42 aside for our testing, right? So we are going to use this, and we are going to predict our y test over here. Right, so this is our Y test. That is what we are trying to predict. We're going to use just this marriage and then population to predict these values, right? That is where this thing comes inside. You will be able to build a model. Now you want to to predict something. You'll be able to fit your model. So what you are going to do now is to predict um, the Y test. That is the divorce cases based on just this population and then what marriages, right? So if we execute this code over, so we just do model.predict into bracket our X test. That's the data you set aside for testing. And I want to print the Y predict. I want the Python to print out what the values for me. That's the predictions. And I want Python to tell me the type of what data set it is, whether it is a series, data frame, whether it is an array or whatever it is. Python will be able to tell me what kind of data it is, right? Alright, so now you see this is what an array, right? And it has been able to predict this value. So means that what 1 5, this is the actual value, which is the 13488, and Python is able to predict the value to be 15114.718. Yes, it has been able to predict it, but you can see that what it has given us the value which is much higher. That is what overestimation, right? The model has overestimated the value, right? And the next value here is what 12927.578, and here is what 177. Means that there is underestimation over here. So it has been able to predict our model, but you can see that you have what overestimation and what underestimation over your of our model. But the good thing is that you have been able to build your first what successful model, and that is what a good thing for you. But if you have not subscribed to my YouTube channel, please subscribe to my channel, and I'm going to be uploading more videos. And if you want me to make a video on anything concerning data science, please put it in the comment section, and I'll be ready to reply you. And I'm going to make sure I go the hard way to find out answers to those questions for you. And I'm going to make videos on that, and we'll keep on learning on YouTube over here. Thank you guys very much, and subscribe to my YouTube channel.